All right, let's start. Welcome everybody to Drake's Lounge for January 2025. Couple of announcements. The March VLA Conference, the registration is now on the website, and you click the more, and then it gives you either an online or an at-site registration. Online's $15 and at site is $55, and the $55 takes care of lunches and various other things for the members, because they'll also be traveling and they'll have their own hotel reservations and things like that. So we try to keep the cost pretty down for the on-site people. We understand that Jason is there now as an employee, and he just got an office. So if the conference room fails, we'll just use his office as a member. Is that okay, Jason?
Yeah, I can probably hold about 10 people in.
All right. Well, that might be enough.
It's actually a pretty decent office, but
is your office at the site or is it at the Socorro?
It's at Socorro. It's at the Science Operations Center.
Great. Okay. We also have a milestone completion. Tom Crowley, who has been the past president and so many times and has been running the grant program and the Itty Bitty Telescope program, has decided that he can no longer solder really small parts for the Itty Bitty Telescope. So we're discontinuing the Itty Bitty Telescope for Sarah right now. If anybody would like to take that over from Tom, and it basically is putting together the swivel mount and the converting the satellite receiving module so it has an audio output. That's what, and he converts that, then he sends that kit out. So right now we took it off the menu on the store. We're no longer providing itty bitty telescopes, and we will, if somebody wants to take that over, it's a long-term thing. We have a couple people doing, super SIDS and scoping the boxes and things like that. So it's a unique opportunity to work with Sarah, and we reimburse you the costs of building these things. So you don't lose any money, just provide a service for the radio astronomy community. Okay. That's all I've got. Tom, our distinguished treasurer, do you got anything?
Yes, I do. I did want to comment about Tom giving up the Itty Bitty Telescope. And I think he's been doing that for more than 20 years, which is a long run. And I want to say well done to him. I didn't see him here, but if he is here, it's well done. He said he would the other thing that was happening is that there's going to need to be a price increase. We could no longer really afford to do this for the $89 that we're currently using. And I asked him if he would price out what the newest price would be, under the assumption that at some point we might be able to find some technician who can do the modifications to the receiver unit. But that's something in the future, and we'll see how that goes. The second thing I want to comment about is things on the store. Yes, the Western Conference is now online. You can register for it. $15 for the online version and $55 for the in-person version. And if you are registering for the conference, or if you're doing anything on the store where you're paying money, where you're paying for somebody else's either membership or a registration, or if you're doing multiple registrations, it's really, really important for me if you will include the names of the people and the contact information of the people who are being registered in the additional comments section of the checkout form. If you do that, I will see that, and that saves me having to either email you to ask questions or if I have to go hunting for it elsewhere. So if people would do that, that would be very helpful. Some people who have done registration where they have one person is paying for multiple Sarah memberships, they have learned to do that since I've been doing this now for over a year, and they did include that information. But it really helps me to quickly process stuff if that information is included in the additional comments. And anything else you may think that you need to include to do that. Let's see. Oh, okay. Anyhow, that's where we stand. That was the comments I wanted to make about the store and such. And I will turn it back to you, Rich.
Thanks, Tom. Okay. Just a reminder on membership. We went from about 700 people in our total database to about 485. And the 485 are the people who have updated or either life members, honorary, or paid their 2025 membership. Okay. So anybody who has not paid that is no longer getting our emails and our notifications of meetings and various other things. So just realize that. And so our membership looks like it dropped to 485. In reality, we just cleaned up the database, and most of those people were not responding to emails for a long time anyway. And a lot of that had to do with the 2020 pandemic, and people jumped on board and then they never renewed their membership over those 4 years or so. So I think we're the best membership database right now. Tom and I have been keeping that up in the MailChimp account, and you get those notices. You don't get notices at least 3 times a month, then your membership is probably not updated, and you should contact me or Tom, and we'll work that through. Okay.
Actually, Rich, can I jump back in? One other thing I need to say about the store. If you want to register for any kind of the meeting or conferences, or if you wish to buy journal access or past proceedings, you need to be an active member when you do that. So right now, all the active members run through July of this year, effectively July 1. Memberships expire in June. And so coming July 1, you will need to renew. But since both of the conferences this year are in the first half of the year, you can get away with that. But I did see one person who I have not been able to get back in touch with who did register but are not a member. So it used to be that the conferences would ask you if you wanted a membership, and it became confusing because there are people who have life memberships who do not have to pay annually, and that is how it works. So if you need to check your membership, which is most likely if you've not been receiving emails, there's 3 standard emails a month. If you're not receiving that, you may not be a member, and you can either write me or write the membership chair or write Rich, and we'll look that up for you and get back with you. I probably should have added that too. Okay, now I think I'm done.
Thanks, Tom. Let's go to our time zone challenged people. Rob Lucas, I think you're the earliest in the morning person.
Good morning, everybody. How we doing today? So Happy New Year and all that good kind of stuff. Let's see if we can make this work this time. What do I have to do? So I'll share my screen. And I have to make certain I get the right one. I hear voices in the background.
Okay, we see it.
Can you hear me now?
Yep.
You see it? Anyway, back in the end of September last year, what I did was I flew from Sydney to Los Angeles for a couple of days, and then flew down to Santiago, and then from Santiago to Balmaceda. And this is what I was seeing as I flew from Balmaceda to Balmaceda from Santiago. And I'm thinking at this time, not going to see the annular eclipse. Okay. And as we're driving along, this is what we saw out the window when we went through one of the passes. And I'm going, I'm really probably not going to see the annular eclipse. So we continued on. And when I got there, this is what the sun looked like just before the annularity. Okay. Here's the start of it. Okay. And this is with the C star, a little, zoomed in on it just for the fun of it. Okay, now this is what the clouds were doing just before the annularity. And you can see the bouncing around of the C star. That shows you how much wind there was. Okay, we didn't have to see anything more of this. Okay, this takes a little bit of time to get through. I don't know if I can speed it up for us, but this shows, what the breezes were doing at the time. Takes a little bit of time to get there. What this shows is how, what you can do with a 2-inch aperture, small telescope. And this thing was, actually tracking. It's the same one I took to Dallas for totality that didn't work. But even though it looks like it stopped, you can see, you can see the, I don't know if that, so you see this part's where it's actually starting to fill in. Anyway, now this is with the P1000, and it was just on a tripod. It's a Nikon. It's an 80 millimeter. This is trying to keep the image in on a tripod, just trying to keep it. What you can see at the top is, there's Bailey's beads starting to form. And you can hear the wind in the background. Moving on. Here's what it looked like after the annularity. Now, so anyway, after annularity on the way back up to Balmaceda, we stopped at what they call the marble caves, in Chile. We didn't know that they existed, but what we did was, stop and have a look at it. So we do other things other than, going to see the annularity. So anyway, so after we got back to Australia, what I did was I assembled Alex Pettit's antenna, the Yagi antenna, and, we finally got it to work after stumbling through a whole bunch of new problems. The basic problem was the brand new SDR didn't work, and I thought there were problems with other things, and finally sorted that out. And then I found out that Windows did an upgrade, and what they finally did was Microsoft required you to have an online account check-in. And so I thought my, one of my Lenovo computers had died because I couldn't log in. Well, it took a while to figure out that Microsoft in their update, made me have an online account so that when I logged into the computer, I was, logged into their store. But anyway, so I finally did a scan with, Alex's antenna and a working, system. And this was the first scan that I got. And I'm in the process of changing the antenna to something I can move around and do other scans with. But it does seem to work. Also on the trip, I plugged in the C star, and this is the comet that everybody was looking at. Not too bad for a 2-inch aperture. And I took a photo of the moon just for fun. Now this is the Orion Nebula, and what I did was I'm learning how to do mosaic with the C star. This is about an hour, to imaging the Orion Nebula. Okay. I think we're done here. I hate when it does stuff like this. There's got to be a way to stop all of this. I think if I tried this, nope. whatever it's doing.
I got it.
You got it? So anyway, so I'm back. So any cool questions or any comments or, you know, I could take a lot of time to talk about the specifics of everything, but anyway, you know, I did what I said I would do last month. Yeah. So I'll give you a brief update.
Did you get a chance to see Alma while you were in Chile?
What's that? What's Alma?
Alma is the millimeter array.
No,
Okay.
no, I didn't get to see it, but I have been where you're working. And, you know, do they still have the big, you know, computers downstairs?
Yes, they do.
They actually let us, you know, image another eclipse, you know, out by the antennas. So what have you learned about Socorro?
Well, I have lots of stuff to share when it's my turn. Let's put it that way.
Okay, I forgot about that. Okay. Anyway, I'll have a look at Elma. And I have been to, you know, to La Serena, you know, and I did a total eclipse with, you know, with a bunch of my friends. And I think one of the people that works where you're at is also a Williams College graduate. And, you know, and what he did was they were supposed to be doing a imaging with Socorro, with the large array of the sunspots as the moon went in front of it during the eclipse years ago. I don't know what happened to them. Anyway, we'll wait for you to do yours.
Thanks, Rob.
Hi, Rob. Can I ask a question?
Sure.
Yeah. So you were talking about, sorry, just a comment first of all, just say the C star. And anybody that's looking for a bit of a visual fix while doing mostly radio astronomy, you can't recommend the C stars too much. It's so easy to use. But the question I wanted to ask you is, you were describing some problems with Alex's great antenna. I have experienced, or am still experiencing problems with it. It's probably my complete incompetence. In fact, it's almost definitely my complete incompetence. But I want to ask you, perhaps you could talk through a little bit more what issues you'd had with it and how you solved them. And it may be that one of those will trigger an idea for me that I could use.
Okay. I didn't have any trouble with the antenna. Okay. What happened was when I put the system together, you know, I went to see, you know, if it worked, and it didn't work. And what I thought I had done was shorted out, you know, the input to the SDR from NRAO. Okay. And so what I did was, you know, I was like you, I wasn't thinking, I was more concerned about, you know, shorting out the SDR. And what I did was isolated, you know, the exciters from the feed in the antenna. And Alex explained to me that that wasn't the way it worked. So it wasn't a problem with his antenna. It was a problem with me, you know, going off on a tangent, you know, with the SDR, thinking I'd shorted it out. Since then, you know, NRAO has sent me a new SDR, and I put it back to the way it was supposed to be, and it works just, yeah, it works just fine. So I didn't have a problem with the antenna. Okay. Now, what the other problem like I said, was, you know, the SDR didn't work, so I replaced that, and it now seems to work. But what the other struggle is with, you know, I isolate the internet, you know, and turn off the Wi-Fi, you know, for the computer, you know, trying to reduce some of the noise. And what, you know, Microsoft did was, oh, the computer just sits there and it doesn't even time out. It just looks at you and says, you know, the blue screen, I think it is, and you can't log in. And what I found out was, as soon as I took the computer and put it near Wi-Fi, oh, it logged on. And I, you know, after I spent a whole bunch of money, replacing memory and everything and restarting the computer, you know, only to find out that you have to have a Microsoft account, you know, to log into Windows with 10 and 11. So there wasn't anything really wrong with the system. It was just me, you know, stumbling through all the hurdles that Microsoft put in place. Does that answer your question?
Yeah. Well, yes. Thank you.
Did you have yours working?
Well, it seems to give a very flat signal with not much signal. Alex sent me a few ideas, which I'm going to try out. But yeah, I just was looking for whether you had any further ideas, which I could try. But yeah, it's fine. Thank you very much.
What I do to make certain things are working is I go out and take a look at the subword and make certain that the bias T light is on.
Yeah. I mean, just a suggestion for your problem about connecting to the Wi-Fi. Why don't you put your computer into airplane mode?
I hadn't thought of that. I just switched everything off and just leave it. It ran for 4 months.
Yeah. I also have, if you're interested, I found a very nice little app on the internet, which I could send you, which is called Windows Update Blocker. And it's quite brilliant. If you go into Windows Updates, it doesn't matter how many boxes you tick to say, pause the updates, don't do the updates. They still seem to manage to crawl through, but this little thing, wob, just hits it straight on the head and nothing then updates at all. So if you're interested in that, just send me a message and I'll send it to you.
That's okay. Thank you.
All right. Thanks, Rob. And Andrew, why don't you go next since you've already started? And we got a lot of new members online now. So why don't you tell you basically where you're located? Everybody tell you where you're located when you start out.
Okay. Well, thank you very much. Yeah. So make sure I've got my audio on. I usually haven't. So my name's Andrew Thornett. I'm a medical doctor. I am a doctor, but a medical doctor rather than a physics doctor. I think located in the middle of the United Kingdom, just above Birmingham for anybody who's been around here. So we get an awful lot of cloud and radio interference. But yeah, I find Sarah's a really fantastic group of people. So I can't recommend the group too much to anybody who's interested in radio astronomy and needs a bit of help. So in terms of what I've been doing this week, so again, for the new people, they may not know some of the things that we're using. So do you think it'd be worth, Rich, perhaps we just explain the background a little bit to some of the things as I go along?
Yeah, go ahead, take a few minutes.
Yeah, well, I won't take too long, but rather than assuming people's knowledge, I will explain. So many of us are trying to record hydrogen from the Milky Way. This is the main thing that I do, amongst other things, but which interests me. So that's 1,420 megahertz. And by recording that, you can map out the Milky Way arms. You can also weigh the Milky Way, and you can demonstrate the smoking gun for dark matter. It's pretty impressive. And more recently, we've managed to be able to, initially Alex Pettit started it off, and then Ted Clyde has taken it further, and we're now actually doing 3D plots or 4D plots, depending on how you look at them, of the Milky Way structure of the arms, which is really blows my mind. I think it's actually fantastic that we can do things like that. So personally, there are two different types of software that you can use to collect your data. One is called SDR Sharp, and another one is Ted Clyde has produced something called Easy Radio Astronomy, and Easy Radio Astronomy is my personal favorite. So I mentioned before that I was having some issues with my aerial that we call them in the UK, we call them aerials rather than antennae. Aerial that Alex had very kindly made for me. And I know it's been cut correctly because he sent it out to me complete with cut bits and pieces. So I hardly had any work to do to put it together. But for some reason, that isn't performing as well as my other hydrogen radio telescope, which is based on an old military array. And it should perform better than that previous military array. So something's wrong. I don't know what it is yet. I have been a bit stuck because I had a knee operation and I've gone back to work, which has limited my time. There's been some issues. The fact my mum died and we're trying to clean the house, but hopefully now I'll get a bit of time to try and sort this out. And one of the issues I've got is Alex produced some excellent software called H-Line 3D, which allows you to do some very impressive plotting of your data from hydrogen. and it's available on GitHub, which is a location you can go online and get all sorts of free software. So tried to get that to work. I've had some issues getting that to work, and Alex is kindly helping me out with that. So once I've got that working, I'll be able to not only use it to test my configurations on my aerials to try to sort it out, but also I can then reprocess some of my older data, which is also interests me greatly, because Alex has suggested some various ways of plotting it. My problem is it's all being collected in easy radio astronomy rather than in SDR sharp, and the software is designed to process SDR sharp files. And I hope Ted will not tell me off for stealing his thunder a bit. This week, as in over the last 24 hours, I am the lucky person to be the first person to attempt to use Ted's new bit of software for easy radio astronomy that he's produced, which is a neat little Python script which allows you to take data that's been collected in easy radio astronomy and convert it into SDR sharp data files. He's had for a long time something to convert SDR sharp data files into easy radio astronomy data files, but this is going the opposite direction, so that you can now take your easy radio astronomy collected data and use it on the various programs that Alex is now producing. So go back and forth. So that's what I'm doing at the moment, attempting to do that, and hopefully be able to plot out the stuff using Alex's software, and also at the same time then use that for testing the Alex Pettit plate Yagi and finding out why it's not working. That's what I'm hoping to do.
Okay. Thank you. Anybody got any questions? All right. Okay. Edward.
Sorry. Before you do, could I just say, is Alex still online? If he is, he did kindly offer to go through something for me at the beginning of the meeting, but I didn't see his message until as the meeting was starting, so I missed out that opportunity. And if he would like to, Ted and I are staying online on this call after the end of the meeting, and if Alex was around, perhaps he could join us for a few minutes and just also go through his software and hopefully help me to get it started.
Yep, I'll do that.
Thanks, mate.
I have a quick question for Andrew. My name's Adrian.
Hi, Adrian.
I was curious if you've done any more work with your solar cooker antenna and refined any results from that.
You know, I've been deliberately avoiding mentioning. I've also got problems with my solar cooker radio telescope. Don't ask me why. I got to go to that one as well. I've got two to sort out. Alex keeps telling me I should change the configuration on the Ptarmigan ex-military array because it's not performing at its best possible way it can perform. And I'm sure he's absolutely right, but I dared touch it unless it stops working, and then I won't have any that are working. No, so again, there's people who are brand new. So you might be considering doing something like this. And there are various bits of kit you can buy, and obviously various amounts of money that you can spend. And some people here have 3-meter telescopes, and Wolfgang has access to a 10-meter telescope, and wow, 10-meter wide dish or 3-meter wide dish. But obviously these things are very expensive, and so all of us are wondering how we can do them at a much cheaper price. And one of the things that's come up recently is that on eBay there in America, they're selling what they call parabolic solar cookers, which is basically a satellite dish 1.5 meters wide. So it's a very decent sized dish. Comes as 6 or 8 petals that you put together, and they're only $50 or $70 plus a bit of postage. In the rest of the world, you can still access these things if you want them. They cost about the same price, $50 or $70 or pounds or euros. But then you also pay postage, and they come direct from America, which is usually about sort of another $70. But I mean, nevertheless, $140 or £140 or euros is still a very cheap price to pay for something 1.5 meters wide. And there are very good physics reasons why those dishes are absolutely fine, even if they're not quite as accurate as a good going satellite dish would be. So I was able to get hold of one of these things, and I mounted it in my garden, and I should be seeing staggering signals coming through. But it does view the Milky Way, it just isn't doing it with the signal strength that it ought to do. And so I'm still again trying to sort out why that's the issue.
Thanks. Edward.
All right. Good evening. Can you hear me?
Yes.
Great. Okay. So for those of you who are new to the Sarah meetings, I just quickly introduce myself. So my name is Edward. I live in the Netherlands. My main focus within radio astronomy is on so-called masers. Masers and masers, if you are not familiar, are essentially the microwave equivalent of lasers. And interestingly, they occur naturally in outer space, in places like star-forming regions, and they are very bright and very variable. So they are interesting targets to observe regularly over time to see if there are any changes occurring. But that's not really what I'm going to talk about today. So today I have a couple of slides about some other observations that I've been doing on the galaxy Messier 33 at the hydrogen line. So essentially, it is not only possible to detect hydrogen line from our own galaxy, but of course all the galaxies have hydrogen as well. But because they are very far away, it's a very faint signal and it's quite challenging to detect that signal. So let me share. Okay, I hope you can see this. Now I'm going into presentation mode.
Can we see it?
Yes, great. So I'm doing these observations with this 3-meter dish in the backyard. It's actually not permanently set up. It's essentially like 4 segments that I can assemble together to form this parabolic dish. But if the weather is really bad, I just store it in the shed for a while. And in periods of some good weather, then I just assemble it and just collect spectra and observations for a couple of weeks. So last time during the R-Top in December, I already shown my observations of the other galaxy, Messier 31, the Andromeda galaxy. So since then, I've been collecting transits of the galaxy Messier 33 and in an attempt to detect Messier 33. So Messier 33 is a bit more challenging because it's fainter. So Messier 31 is a maximum flux density or brightness, if you will, about 120 Janskis, and Messier 33 is only about half that level at about 60 Janskis. So really, really tricky to detect. So in the meantime, I have done some work on the feeds over the Christmas break. So I have been, so this feed that you can see here, this green feed, is a W2IMU type feed that I initially made for 1612 megahertz, which is the frequency of the OH masers. But of course, for 1420 megahertz, this feed is not very optimal. So I made another feed for 1420 megahertz, but unfortunately, I'm not really seeing any great difference in the signal to noise ratio, my observations. So perhaps it didn't really matter. So just as a quick reminder, of course, last time when I discussed my observations of Messier 31 during that R-Top in December, I already discussed or already told you about the procedure that I use for data collection, but just as a short reminder. So essentially, I'm doing drift scans. So the dish is sitting stationary on the table, pointing south at the declination of the target source, in this case, Messier 33. So every day the source passes through the beam, and then I just collect spectra every minute using the SDR Sharp IF average plugin. And so the transit of this object, of this galaxy, takes about 20 minutes through the 5-degree wide beam. And I use a set of spectra from about 20 to 10 minutes before the transit, and another set spectra from after the transit for the bandpass correction, so to remove the spectral response of the SDR. So this time I had a little bit more troubles with RFI. So at these very weak signal levels, RFI can be quite challenging. And even though I have a pretty good filter for 40-20 megahertz, sometimes still some issues with the RFI situation. So here you can see an observation from the 17th of January, and you can see that the background level essentially of the spectrum is varying quite a bit. So you can see these horizontal bandings, and here you can see this as well in my set of spectra that I collected over the past month from 6 different observations, and you can see 5 of them are pretty okay. They're quite nice and flat, and then the 6th, the one from the 17th of January, so this light blue line, is very curved. So I couldn't use that. I just couldn't properly correct the bandpass slope for that observation due to some RFI issues. It may be possible to fit a curve through this, but then yeah, at this very low signal levels, it's all quite difficult. So I just left that RFI affected observation out of the final average. So what I then did is for the 5 remaining spectra from these transits, I averaged them together. So remember, for each transit takes about 20 minutes. So this is about in total about 100 minutes of integration time. And what I also did is that I reduced the spectral resolution to 58 kilohertz by averaging each 3 spectral bins. Because we don't need a whole lot of spectral resolution for these galaxy spectra because they're really wide. And reducing the spectral resolution by reducing the spectral resolution, you can gain a little bit of signal to noise ratio. So the end result is not very spectacular. So we do see a slight peak at around minus 250 kilometers per second. It's somewhat a plateau, maybe, but the signal to noise ratio is really poor. So this peak at minus 250 kilometers per second roughly coincides with the blue shifted peak that we would expect from Messier 33. So these galaxies typically have like a sort of like a double peak spectrum. So one peak is from one side of the galaxy that is rotating towards us, so the blue shifted, and the other side of the galaxy is rotating away from us. So we expect to see a red shifted peak from that. But yeah, so that leads to a sort of characteristic double horns profile, but that's strangely enough not really what we see. Apparently we see the blue shifted peak of Messier 33, but the red shifted peak, which we would expect at around minus 100 kilometers per second, is absent. I'm not sure why this is. Maybe it just needs a couple more transits. It just needs more integration time. But yeah, so far, like, this is a pretty marginal detection, but perhaps a detection nonetheless. So that was it for today. Are there any questions?
On that last slide,
Yeah.
bring it up. I'm confused. One says M31, one says M33.
Oh, yeah, sorry, that's my mistake. Yeah, that's just a typo, sorry.
And so the whole slide is for which one?
It should be Messier 33.
Thank you. Okay, good.
Yeah, I just put that together like right before the meeting, so...
Well, I fully understand. Well done.
So I had a comment. So first of all, well done. I as you know, I've messed with this same thing over the past several months. Well, over a year, almost a year. But I succeeded back in April, I believe, of last year. But one of the things that I found that might help I found that when I first started doing it, I was using my calibrate. I was making my fore and aft calibration times separated by 5 or 10 minutes from the main beam. And I found that it actually helped if I put them right up against it. And I'm not sure why that is, but I experimented. I did, because all the data is there. So I experimented around and I found that it was actually better if I made my calibration as close to it as possible.
Yeah, I think it's a bit of a trade-off in that case, because on the one hand, I think you're gaining some signal to noise ratio because you have like less time for the system to have thermal drift.
Yeah.
So your spectrum is your baseline is going to be flatter, which is better. But on the other hand, you lose a little bit of signal because if you're going like right up to the transit, you're already getting a little bit of like this galaxy signal in your beam. So
Exactly. Yeah. And so, like I said, I just experimented until I found that it actually was better to be closer rather than farther.
that's interesting. Yeah, I'll definitely try that. That would be a fun little experiment. Thank you.
The other thing that I found, at least with M33, because it's fairly narrow, the spectrum is fairly narrow for that one. I found that I did have to use polynomial fits to flatten my background some, but I only ever had to use a second order. It was, and usually it was just a linear fit was fine. So that's what I found with my data anyway. So just some food for thought.
Okay, yeah. I didn't do any polynomial fitting this time, so okay, thanks.
All right. Any more questions for Edward? All right. Dmitri.
I did have one more. Sorry.
Whoa, go ahead.
Real quick,
Are you going to try to go after M101 next?
Perhaps there's another galaxy I have on the radar though, so I'm not sure about the catalog number, but there was one that was around 30 Jansky, so it would be like half of M33. But first, I think I'm first gonna collect a bit more spectra of M33, a bit more transits, to see maybe if I can like improve the signal to noise ratio further, and also perhaps like see this characteristic double peak profile that it should have. And only then I think I'm gonna go after like the really tough ones.
Great. Thanks, everybody. Dmitri.
That's perfect. Also, science read. And I have two things to talk about today. First, I continued observation 6.7 gigabits from W75N. I have two fresh spectra, and for January, this is almost quite November spectrum. So next I can see some variability in this measures, and December 2. In late December, this measure began to restore a quiet state. January spectrum seems confirms this. This line is in beginning of January can be radio frequency interfering. I am preparing talk for Western Conference about W75N, and we'll be talking about in more details if some comments and questions, I will be glad to answer for these things. And I have second things to talk about.
All right.
Just a moment. I can not shared. Not shared. Alright. Not shared. This is November spectrum quite disturbed. November and December spectrum. More January spectrum. Confused. This measure began to return to its quiet state, and maybe some verify lines. If some questions, if some comments about, I can answer. And I have second thing to talk about. Here is some progress. Has some progress in building 43, 44 here receiver for to observe silicon oxide line, measure silicon oxide lines, and possibly methanol line 44 gigahertz. I can show on this receiver just a moment. So you can see this 43, 44 gigahertz receiver. This is just a sample market. This is already in the working state. Black box. This is converter, control of converter, and low noise amplifier for design. This LNA designed for 47 gigahertz band, metric band, but works for 43, 44 gigahertz. Measured noise figure for 47 gigahertz 1.3 dB. I have some measurements for 43 gigahertz by a special method. I can see some video with we'll measure that in just a moment. Sorry, this is with Russian comments. I will translate in conventional English. This is today test for receiver test of receiver noise figure. Which will receiver 43, 44 gigahertz. Horn, special design horn directed to the sky, to the cold sky. It gives a cold temperature, and we compare the noise of receiver with hot temperature that can provide by absorber before the horn. What in such way absorber can provide hot temperature for the horn, and output of receiver, output of converter is going to receiver, measure a receiver that can compare hot and cold temperature and even calculate noisy figure. My result for calculation for 43 gigahertz is about 1 point in because cloud gives very much mistake, very many mistakes in estimation of sky temperatures. 1.8 received for this received for this converter. Nice figure. It's okay. If problem is problem for now is positioning of antenna, accuracy of tracking. I am thinking about how to use now for optical astronomy, EQ mounting. I have no idea how to align it, how to calibrate it, because this do not allow to see the Polaris star from the mounting, and other methods like 3-star calibrations and 2-star calibrations also not suitable for calibration when dish is mounted on when dish is mounted on the system. If some can help, about ideas for the calibration, I will be glad. This is all for now. If some questions, I will be glad to answer. And maybe any comment, I will be glad.
Any questions for Dmitri?
Yeah, did you make your little horn by hand yourself, it looks like, maybe?
Yes, this is a little horn. Just soldered me very quickly. I intended to order better horn for better horn to make by milling and other methods for best accuracy, but it works. Do not receive many noise from walls and ground. Gives gives very good noise figure.
And it looks like you have your waveguide goes through your preamp and then comes from the bottom, the waveguide still, and you make a transition from waveguide to coax or to another signal underneath the black phenolic. Is that right?
Yes. Transition from circular horn to rectangular waveguide is just a bending pipe of circular waveguide, and after soldering it to rectangular hornless flame. Next, the transition from PCB to rectangular horn I made from is calculated by me in modeling program. I can show a probe. In just a moment, I can show a probe for this transition. Just a moment. Just a moment. So this is PCB for the shear. I love PCB for the receiver, and this is a probe. We can be inserted in rectangular waveguide through very little hole in waveguide.
That's very interesting. Thank you.
All right, good stuff.
Yeah, Dmitri, do you think you could use thermal emissions from the sun as an aid to calibrating the pointing and tracking part?
Yes, certainly some is one very convenient source for this guy, but the problem is for big dish, 2.4 meters. So that is the dish is very narrow for sun, and to see only the center of the sun. For smaller dishes about 1 meter, it can be mounted on an optical mounts, EQ and other. It's sun is a good source for aligning and calibration, and maybe not sun, maybe moon too, with not a figure 1.8 distribution will be seen too. Especially a little after full moon phase.
We're going to move on because we got a lot of people to go yet. Thanks very much. Good job, Dmitri.
Thank you.
New member. I think our first Belgian member. Is it Bernheist? Is it Verheist? Who's our new Belgian member?
Okay. Just say Philip, it's more easy.
Why'd you introduce yourself and where you're at and what kind of radio astronomy system you have?
I'm just at the start of everything. I'm living in Belgium, Europe, near the Belgium coast. I'm retired since a couple of months, so now I have more time to do what I want. So that's a short introduction. Today I'm just listening.
All right. Well,
It's a
thanks
start for learning it, yes.
for coming on. All right, let's get to Alex.
Good afternoon. I have kind of an interesting presentation. This is developed over the past week and a half, something I never anticipated doing, and that is sort of comparing some drastically different antennas. And let's do it. And you see my antenna.
We see.
All right. So I have been soliciting some data from a number of people and trying to compare radio telescopes in the 1 to 2.5 meter dish diameter range. And I was offered to get some data from a slightly larger one. So I did some comparison between my 1.2 meter and a 12 meter dish in New Gold, Germany. I haven't read a whole lot about this, but it's an interesting one in that it was one of the few commercial satellite antennas. It was designed to run at 6.2 gigahertz. And so I have some SDR sharp IF average data, which is compatible with the H-Line 3D software. And I've been processing that, and the differences are dramatic and interesting because I've never seen any detailed H-Line data from a large disk. So this is the difference. Mine is about a 12 degree half power beam width. The German one is 1.2 degrees, though it's even more narrower than this. I have data sets from 30 degrees deck. The problem is the narrow beam width slices through a much dimmer portion than mine, and so my antenna is also susceptible to all this much brighter area around 35 to 38 degrees declination. But be that as it is, these are some of the comparison results. And as expected, the wider beam width of the 1.2 meter dish is broad. It's blurred together because of the wide beam width. In contrast, you get some really interesting high resolution characteristics with the 12 meter that I have not seen before. There's a lot of definition going on here. Some really interesting features to slicing through the Milky Way that I haven't seen displayed in this map. Zooming in, you can see the differences here. A couple of differences. I was running 1.125 degrees. This is 1 degree. I've asked Claus to go back and to capture some data at 1/2 and 1/4 degree increments to really see what the resolution of this system is, because this is way too wide. It has the ability of resolving much better than that. The delta velocity, Doppler velocity on mine is 0.6. His is about 0.4. So his has higher resolution in the velocity. But the details here are really interesting, but there's an awful lot of similarity between the two. Taking a look at the absolute values, the H-line peaks to cold sky. Well, the smaller dish is higher because it's picking up that higher energies of the declinations in the 35 to 38 degree range. But, and this is what I have been observing, I have probably analyzed 6 or 8 different radio telescopes, dish-based radio telescopes, from mine being the 1.2, so 1.9, 2.4. Is that a typical tuned system runs around in the brighter range? Let's say the Dec 40 runs about 2.5 to 3 dB of signal to cold sky. We'll call it signal noise because this is signal here, but the difference between 10 Kelvin and, I don't know, what is this, 100 maybe, winds up being about 2.5 dB. So, some observations. Milky Way interstellar mass clouds are extended sources, so all or a large part of an antenna's reception beam is filled by a signal. And so theoretically, if the hydrogen emission was completely uniform, like a fog on a foggy day, large and small dishes would have C-identical signals, and the H-line to cold sky levels would be exactly the same. This is characteristic if you've ever done optical astrophotography with the same type of a CCD or sensor, and let's say an F ratio, f4 telescope will have the same brightness regardless of its size. A 2-inch to a 20-inch f4 telescope will have the same brightness. You will get the same number of photons per pixel on either one. Obviously, the larger telescope being a much narrower field of view, but this kind of analogy holds true, and it's valid because most radio telescopes run about 0.35 to 0.45 F to D ratio. So there's a parallel. And with identical systems, the differences pretty much correlate to the performance of radio telescope systems. So this is a useful way of evaluating the performance of your telescope. If your dish system's running about 2.5 dB to the bright area in Cygnus to cold sky, it's probably up to snuff. If it's running much less than that, may need some tweaks. This is the antenna. It's pretty spectacular. The one thing that's significant about this that I've not seen on other telescopes is that it is deep. It is I don't have the characteristics of this other than knowing that it's a 12-meter dish, but this has a very deep dish. This should have extremely good signal to noise to spillover from Earth or RFI. So this has some interesting capabilities that I've not seen in the others. And this is really active because I just got this. These are comments from just this morning that I asked Claus what was the plan of this telescope, and they are the drive system needs to be repaired, but they want to start doing their own H-line survey, and they're working with this professor from the University of Kiel in Germany, and it's a pretty spectacular setup. And for them to want to start doing some H-line mapping, it gives some pretty interesting results. This was the 54-hour full data set that he sent me, and then I processed with the H-line 3D software. There's one view, there's another view, and if you study this, there are some differences. You figure there's a small drift in LSR that's not being corrected, but there's an awful lot of details that repeat. So there's some real information here, some very interesting detailed information of these sweeps through the Milky Way. And here's a zoom in. Here's 2 6-hour segments a day apart, and there's a lot of similarity between these two. And like I said, also this 1 degree, I think is not acquiring the optimal resolution, angular resolution of that telescope. This is a link to the professor that is going to be helping Claus and company with this mapping. And if you go to this website, there are slices through the Milky Way that you can plot of spectral slices. I haven't gone through this, but you can go through and you can look at various slices through the Milky Way. And for those who are not familiar with TAE, do a search on H-Lines 3D, and it'll bring up this information. It's a combination. If you want to build a nice, portable, low-cost telescope, this is it. This works out pretty well. There's a couple variations on it, but all of the information, the developmental information, the modeling is on this GitHub website. And then working with Jameson Adcock, he produced some software that we've been modifying, and it produces some pretty spectacular 3D graphics. Any questions?
Very exciting, Alex. This is great.
Yeah, it's kind of different. That's, like I said, I've never seen data from a large telescope like that. So we'll see where it goes. Thanks, everyone.
All right. Thanks, Alex. Good job. Jason.
All right. So rather than a presentation, I'm just gonna, so as you all probably know, I just arrived in Socorro, New Mexico, almost 2 weeks ago now. And I'm now working for NRAO, and so I'm actually having my hands on professional radio astronomy hardware. And so I was just going to show some photos of what I've been able to enjoy so far here. Let me share my screen. Let's see here. All right, let's see if this is going to. All right, so this is what I see out of my window every morning. It's just spectacular.
Can you zoom out a little bit?
Oh, there
There
we
you
go.
go. There you go.
I'm not sure why it's not letting me zoom in here. Oh, well, anyway, this is the Science Operations Center in Socorro. That's where my office is. That's where I'm working. And this is also where the Western Conference will be held for the most part, in the main auditorium in here. So there's a close up. And when I arrived on my first day, they actually had my name up on my office. I actually have an office, which was in my previous job. I was just in a cube. So that was kind of nice. I personalized my door a little bit, put some of my galaxy observation stuff up. And yeah, I've got a couple of nice big flat panel screens. Okay, I think that's it and one of the cool things is I have live access to the IF feeds on all the antennas. So I can literally look at what's coming through. This is live IF feeds coming from the VLA. And as you can see, you can select any antenna from 1 through 28. There's 28 total. Usually one of them is down for maintenance. So they usually have 27 of them deployed on the array at any one time. So that's pretty cool. Let me see if I can. Okay, so I got one of the things I did is on Wednesday is maintenance day out at the VLA. And so they take it down for maintenance. So I was actually able to have a close-up personal tour with antenna number 11, which is the first one on the west arm of the Y. And it's also the one that's closest to the walking path that you will get to see on the tour if you actually come to the conference. So this is on the walk up to it. And there's a close up. And then we're going into the room at the base, and he's locking out the motor drive, calling back to the control center to verify that it's locked out, and then we're going to go ahead and climb up on it. All the cabling from the feeds is coming down this central axis, and it can spin freely so that it doesn't get tangled up when the dish rotates. One of the interesting things, so this is the elevation gear. Those motors are really small. And this gear reduction is so insanely large that the mechanical advantage is so great that if they lose power, they can literally move the dish with a hand drill. It takes forever, but they can actually move it with a hand drill. That's how good the gear reduction is. This is the cryogenic coolers that are cryogenically cooling the feeds. The front ends are all cryogenically cooled to keep the thermal noise down. And here we're going up into the vertex room where the feeds are. There's the electronics bay where the IF LO and IF channels are, and also where the digitizers are. There's one of the feeds. I believe that's the base of the L-band feed, which would be the one that is looking at hydrogen. And then that's the IF rack there, so you can see. And then some of the other feeds. Okay, so then this is the hatch that opens onto the dish. We actually got to step onto the dish itself. There's the prime focus, the secondary reflector, and this square thing is actually it's actually a 4-meter dipole array at the prime focus that NRAO added as part of an add-on, and basically they have their own correlator for that, but they also allow the regular VLA receiver and correlator can access that IF feed as well. And there's also a smaller dipole that's hidden behind my head that's for P-band. So the two lowest bands are at the prime focus, and then all the other feeds are at the base of the dish, and they use a secondary reflector that's asymmetric, and it rotates to focus on whichever feed they're wanting to tuned to at that particular time. And there's a picture of me in front of the feed assembly. The L-band feed is huge. It's like the size of me, so it's pretty amazing. Okay. And then we got one more to show you. I got to go into the giant Faraday cage that holds the correlator. The correlator is where all the magic happens. So they digitize all the IF channels and send them over high-speed fiber optic to the correlator in the main operating room, the main operations room. And that's out. That's the kind of the central building out at the actual VLA. And this is the correlator. This is where all the channels are cross-correlated from each of the 27 antennas to create a giant interferometer. This bay right here is there's a single rack here. That's the NRAO V light, and that's their separate correlator that the Navy is using for correlating that extremely low band signal from those 4-meter dipoles, 4-meter band dipoles. This is the UPS for the correlator. Yeah, pretty big. We had to wear smocks and booties because this thing is a one-off and they can't afford to have ESD damage or anything like that. So it's treated with kid gloves. Let's put it that way. There's all the optical feeds coming from all the IF channels into the different sections of the correlator. So yeah, I hope everybody really gets a chance to see some of this stuff when they come out for the Western Conference. I guess the only other thing that I want to mention is I found out I was in touch with Ken Redcap, who's the coordinator of the Western Conference this year. It took some digging, but I finally found out who his point of contact was on our end. And it turns out that he had a schedule conflict that was unexpected that came up. And so I have actually volunteered to take over the coordination on the NRAO side. So Ken and I are going to be working together to make sure things happen the way they're supposed to be. So I figured it was a good fit because I'm a member of SARA and now I work for NRAO, so I can kind of play both sides of the fence here. So I did have one question. I don't know, maybe Rich, you could answer this or somebody, but so the auditorium, according to our front desk admin person, the auditorium holds 60 people when it's in its auditorium configuration. So my question is, what do we anticipate the number of on-site participants possibly will be?
It won't be 60.
Okay. Yeah, because if we thought there was going to be, a chance to be greater than that, then we might have to coordinate using the Macy Center, at that NMT or something. But it sounds like we'll be fine. So,
Agreed.
all
Tom,
right. That's any questions or comments? That's pretty much all I had for now. But
thanks, Jason. Thanks for taking on the coordinator.
Yeah, I had
It's gonna
a
help a
quick
lot.
question.
yeah,
Yeah, are there any prototype NGVLA antennas out there, and are any, if so, are any operational, and how do they compare to the current VLA antennas?
okay, yeah. So there's one prototype that's still under construction. It's, as I understand it, it's getting close to being at least mechanically ready to go. I'm not sure what the timeline is at this point for them to actually turn it on and start testing it. It's slightly smaller. Those dishes are slightly smaller. I don't know the exact figure off the top of my head, but they're not quite as big as the old VLA dishes, but there's going to be way more. The plan is that there's going to be over 200, some of them, and they will be in kind of a nested configuration where there'll be like an array within an array within an array. And so the center of it will be clustered close together at the VLA site, and then it will extend out, and it will extend, I think, several hundred miles out eventually is the plan. So it's the idea is that it'll be instead of right now, the existing VLA, they have 4 different configurations, 5 if you count a hybrid one that I'll talk about sometime later. But there's basically A, B, C, and D configurations. D is the tightest; it's about a half a mile wide, and then A is the most extended, and that's close to it's over 22 miles across when it's extended into A configuration. And actually, right now and through the beginning of February, they are in A configuration, so they're at the highest resolution configuration at this point. So,
And I was hoping to give you an action item for a later talk, maybe as a talk about their timing source, what their time base, how it all works, and how they correlate with other facilities like ALMA or whoever else.
I can tell you in one word: hydrogen maser.
Mm-hmm.
They have they have a hydrogen maser similar to each of the VLBA dishes, which that's a whole other topic. Have each of those sites individually has a hydrogen maser so that they can correlate those. They can't do those in real time. They have to send the data on FedEx and send them back to the operations center, and then they plug them into racks and they correlate after the fact. But yes, they need a hydrogen maser to have a tight enough time stamp in order to do the correlation.
And then they phase match all of these antennas through software, or do they actually have the fibers all tried to cut them to the right length so that they're all round?
I think that they do rough phasing with the lengths of the optical fibers, but then there's layers, so they refine it, and the rest of it is done in the correlator with software. So
Okay, great. Thanks for all the information.
I have a question. Do you know by any chance when the VLA comes online, will the VLA be decommissioned, or will it still resume operations?
yeah, so the way I understand it, they will not start shutting down the existing one until the NG meets or exceeds the performance of the existing one, because their charter is they got to stay up. You know, they're a global asset that's available to the scientific community, and their charter is that asset needs to be available as much as possible. So I think the answer that I've gotten so far, because I've been asking that question as well, is that if and when the NG VLA meets or exceeds the performance of the existing one, then they will start systematically decommissioning the old system, but not until then.
Jason, thanks for all your help. This is great. I sure enjoy that tour. Leaf in the chat asks, what is the NRL actually using that 4 meter antenna at the focus 4? What are they studying? Any idea? Or can't you tell us?
Well, I no longer have a security clearance, and I'm no longer working for the Department of Defense, so I do not know the answer to that, but I don't think they would tell me, even if unless I was an inside person on that. But I do know that my guess is that it has something to do with geospatial stuff there, because they're dealing with a lot of those low band stuff, even on the VLBA. The scientific community, the geology community, is actually using some of that data, because the geospatial accuracy of that low band information allows them to actually track the movement of the tectonic plates. It's pretty wild, actually. It's pretty amazing.
Neat stuff. Well, I'm impressed how much you're absorbing. Well done.
Jason, this is Tom, the treasurer. I can tell you that the number of people that came the last time the Western Conference was in Socorro, it was somewhere between 20 and 30 people on site, and that was pre-Zoom. Right now, we have less than 10 people registered, and that includes both the online and the in-person people. So Rich is right. I don't expect us to get to 60 unless there's something really special happening in the New Mexico area at the time. So just to give you that, the last time we were there, like I say, which was was 2016 or 2017 or something like that. I'm going from memory. There was less than 30 people there, as I recall. I was one of the people there. Like I said, that was presuming the conferences. So that answers your question, I hope. And if you have other questions, you can ask me. And if you really need a long explanation, email me, and we can do it that way.
All right. Yeah, that sounds good. One of the things I want to coordinate with Ken is I think it would be worthwhile if we can, when we go out to the VLA, to actually take a little jaunt about 40 miles farther west to Pie Town to see the VLBA dish. I think that would be worth seeing.
All right. That sounds fun. Okay. Thanks, Jason. Okay. We only have a half hour left, so I'm going to hit everybody. And unless somebody has a big presentation, limit your time. I'm going to start with Ted.
Good. Let me get rid of here. Yes. Okay. Audio. And now let's share. Hit share.
There we go.
Okay. That should be good. That should be better. Okay. I think I'm in the right place to do this. Ezra continues to add little features. Now we have stereo movies. Let's go through some of that. We have been making plots of many samples throughout a 24-hour day like this. Time is expressed from left to right, and frequency goes up and down. In that plot, we get to see this curvy snake, this curvy galactic snake, I call it, wiggling around. And when you're looking at the plane of the galaxy, it looks brighter in two places in that graph. Okay, that makes sense. If you take two of those and add it up to 48 hours, you get more wiggles. And there's a way now to present that in a 3D format shown here. So now that wavy snake is curving around on that blue base twice. All right. With this graphics renderer, you can now rotate where the camera is placing a little bit over here to the right, or even farther all the way to the right. So you're almost looking down the graph from the right side as we typically view it. So I've been exploring this. So how do you present all this 3D stuff? How about we present it with two pictures, slightly different camera locations, and now we can do stereo. Give this a try. If you put your thumb, if your monitor is about the length of your fingertips, and you put your thumb about 4 or 5 inches from your nose, and then focus on your thumb with both eyes, you can maybe focus on that thing in the back distance and get one image in a cross-eyed stereo. I see stereo in there. I see points in the back, far away, and points in the front, and then the frame way up close. I'll let you practice this on the YouTube later. I've also posted this kind of stuff on the Ezra webpage, which I'll talk about. Well, okay, that's kind of simple. What happens if we go farther and make a movie out of this? Here we go. So picture after picture, all combined. I'll try to get my cursor out of the way here. if you do that crosshair thing, you can see this cube rotating in space in front of you, and your eyes are indeed collecting that 3D information. This one's kind of interesting, but I don't know if it's really helpful scientifically. We can certainly see the galactic snake wheeling around a little bit better. But there's another movie. This one is of that display of the galaxy radiation expressed onto a ball, which is then we're observing the ball from different angles from the outside. And we can see it be a kind of round ball. Again, cross-eyed stereo shows it fairly nicely as we see these arms of power move across the screen. Another way to express it was the same information, but now shown in a galactic coordinate system, so that the galactic plane is horizontally across the screen. Big blue areas show where I don't have data. There's one at the top and there's one at the bottom. The bottom is where the Earth gets in the way, and the one up near the top coming around now is where up near Polaris, and I just haven't pointed my antenna up that high. In this one, the bumps show as higher bumps of higher energy, just as mountains on that ball. Okay, in stereo. Yet another one is the galaxy that I've come up with, taking cross sections of the galaxy plane. Again, cross-eyed stereo, we can see it kind of flying around in space. I don't think this adds any scientific value, but it is a fun display and just another neat thing to do. We can see it spinning around in the distance. It's almost better if you focus on the center point, which is where us and the sun are. All right, well, there's the Esra webpage. And then I've added more to the Esra webpage, lots more movies as of last night, talking about these different display methods. Most of the top paragraph there are these Drake lounge videos, segments of that. And I've added way down the bottom the shoes amateur data sharing. In case you don't have data, you can come fetch it. When you get data, we want your data to be represented as well. Come talk to me. I hope that helps. Back to Rich.
Okay, great job. Any questions for Ted? All right, Preston.
Thank y'all for getting up the registration. And I am one of those registered, and that's all I have.
All right, great. Ellen.
Yes, this is all really interesting, especially the Esra movie channel. And it was really fascinating to see the angular eclipse at the beginning. Thank you all very much.
Thanks, Ellen. Jack Gansey.
Hi, folks. I'm a new member. I'm a retired electrical engineer, and I've had a ham license since 1969. I'm actually putting together one of Alex's antennas as we speak. I'm waiting for some parts to come in for it. But at this point, I'm just listening and learning and looking forward to, getting more into this.
Great. Glad to have you.
Like to add a quick comment.
Red.
It's critical that you have good continuity between the reflector and the feed. And I didn't see how you built that. You probably should have a aluminum, a conductive element between that and the first director.
Yes, Alex, I read your instructions, and I do have the conductive element. I've used the braided wire as well to make a good electrical contact.
Yeah, try that. You're the first guy that's actually built one of those directions. So if you have some issues, contact me.
Okay, I appreciate it.
Great. Thanks. Let's see, Don Latham.
All right, Jason. Good to see somebody permanently there in Socorro. Go down to the Capitol and have a beaker for me. I used to tend bar there during the Colgate era. So have fun. You'll enjoy Socorro, I'm sure.
Oh yeah, the cap is great.
Yeah. I have nothing of any importance further. Oh, I did have one question. Has anybody ever used a Vivaldi feed for broadband on a parabola? Yes, no.
I've got one. Well, I got several. Yeah.
Have you tried it, Charles?
Yeah. Of course, your face center moves depending on what frequency will concentrate on. So I just kind of, tried to put it at 1420. I think it worked. I didn't really spend much time messing with it to compare because I had the gate feed for 1420. What frequency were you trying to do?
Oh, I was thinking of going some broadband just for fun. How about a cavity back spiral?
No, haven't done that one.
Well, thank you. That's all I have.
Don,
Yeah.
this is Dick in Honolulu. A couple meetings ago, you mentioned that you're having a problem with a right angle SMA connector. I assume that was high loss. I wonder if you have any more information on that.
Oh, no, I don't. I actually didn't have a problem with it. I was questioning whether, or I was actually thinking that people ought to look into it. And I ran across that somewhere online that somebody had questioned the quality of type N right angle adapters, and that they were highly variable in their VSWR characteristics. And so I have no further information.
You bet. All right, great. Bob Strickland.
Yeah, I don't have anything forward here. Go ahead.
All right. Thank you. John Richards.
Okay, I haven't been here for a while. I kind of took a step back, and what I'm doing now, my big project is I have this MIT small radio telescope, which is a 10-meter dish. I'm refurbishing it. I've been able to get the motors installed and get them controllable via a Raspberry Pi. And so now I'm taking a step back and honing up my skills and creating a printed circuit board so I can create a hat, what they call a hat board for the Raspberry Pi that fits right on top of the Raspberry Pi and control the whole dish. So I'm still in my learning phase of how to do things sort of mechanically and electronically. It's going well, slowly.
Well, great. Well, if you got any questions, just get on the listserv, and we'll help. Let's see, AI Envoys, NB0YZ.
Oh, sorry, that's Al Foster.
Oh, I thought it was an 8. Never mind.
That's my ham call, N8OYZ.
All right.
Hey, I was on a couple of weeks ago for the first time. I'm new to this. I just retired. I like the gentleman in Belgium. I just retired end of December, and years of interest in radio astronomy, but just getting into it now. So I'm here to learn. I have just finished putting together the last components of a radio Jove kit I bought in 2012, and I've ordered a Super SID, which I haven't done a thing with. And I also, over the last few months, I built a 1.4 gigahertz horn for H1 and have not done anything with that. So I'm going to have lots of questions, and I think I'm going to look at Ted Klein's Ezra software because I was going to use the SDR Sharp, but that looks like a lot better option for me to get started. So I may be emailing or getting on your site there, on your chat, and asking lots of questions. But for now, thanks for the information, and I'll be listening.
Great. Glad to have you. David Kunzman.
Just really listening. I'm going to planning to get a Super SID probably this week or next week and setting that up. And other than that, I don't really have the space to do any sort of physical sort of radio astronomy other than the Super SID. So I'm going to be focusing on the historical data analysis that you put up on YouTube about, the data reductions for the VLA and the ALMA. So I'm going to be focusing on that.
Yeah, that's really fun, and you do a lot with that. Okay. Let's see. Leaf Hill.
Hey, folks. I just finished building one of Alex's antennas. Thank you, Alex, for the help. One of the things I found the problem I was having if people are playing with this thing is right here. I actually attached an NOVNA right to the feed, and I got much better results than I was getting before. So thanks for your help, Alex. And I still working on finishing it up, tuning it with an NOVNA, using that NOVNA software, which takes a little bit of figuring out how to do, but I've made some headway now. So, and I'm hoping to take it out to I'm gonna try and make a duplicate, take it out to Nantucket's and do two antennas at the same time. One question I have for folks is: has anyone played with? There's a Dutch gentleman looks like on the Facebook group for radio astronomy software named Jan Lostrup, who has a single chip correlator. It runs off of the analog devices 8362, and it seems like it will do 2 antenna, basically interferometry. I don't know if anyone's had a chance to play with that yet, but Ted, I was thinking that would be a great add-on to Easy RA to have that feed from that correlator go in to your great software as a correlated set of data. So I don't know if anyone's played with that yet, but I'm looking at that. That's it. Thanks. Appreciate it.
Leaf, I just want to pass along one quick comment. Open up your analyzer bandwidth from up to about 1200 to 1600 megahertz so you can actually see what the resonance is. Your 80 megahertz bandwidth, you're not actually seeing the resonance of the system.
Yeah, thanks. I did actually do that. Thank you. And I think the screenshot I sent you the first time around was after I had narrowed down to go look at the area of interest. So I did have it wide open after you guys suggested that.
Okay, because there really was no resonance on that narrow band.
Yeah, no, it was well, the main problem was I was running a cable between the nano VNA and the antenna, and I should have just put the antenna right put the VNA right on the antenna, and that worked much better. It was much clearer. Thank you.
All right, great. Good job.
Great fun here, Rich. Nothing to add, and I know you've got to get going, so head off. Take it away. Thank you.
Thanks. Let's see. I got AC.
Yeah, I'm fairly new to Sarah, but I've been interested in radio astronomy for a long time, and so I'm kind of working. As I asked a question earlier of Andrew for his solar Coker, a 1.2 meter antenna. So I bought one of those, and I'm trying to get that system set up, and I'm right now trying to work on the antenna feed for that. And then secondly, I contacted Stephen Sikas, and I'm sorry if I mispronounced his last name, and he's in charge of Sarah being able to utilize the Greenback 20 meter radio telescope. And I attended the single dish school for Greenback several years ago and had access to the 20 meter radio telescope and did some scans of the Orion hydroxyl masers, and I would like to maybe pursue doing some more scans of that using the 20 meter radio telescope. I have not done that as of yet, but I have an initial scan that I did several years ago, and I'd like to maybe compare to see what a more recent scan of that would look like. So that's kind of what I've been up to. Thanks.
Great. Thank you. Jeff.
Not much going on. Just trying to survive the cold here in Colorado Springs, but nothing new. Hopefully be registering for the conference. I got a couple conflicts that I'm trying to deconflict so that I can make it, since it's, like a 7-hour drive from here or less. So, but hopefully be there. That's it for me.
Thanks, Jeff. Bruce.
See, am I in here okay?
You got it.
Okay. There was those comments on right angle end connectors. I'd had problems with right angle end and SMA connectors before. At 144 megahertz, I seem to be fine. At 432, you can see a little discrepancies on some of them. And above that, it's kind of avoid right angles has been my experience. Charles might be able to comment on that as well. Other thing I want to comment on is that I've been looking at a splitter / combiner, which 75 ohm, which people have been using the cable TV things, but I need to be able to pass power through one of these splitter / combiners to get power to some active preamps at my 20 megahertz feed. And the problem is all these splitters you find have isolation diodes, so they only allow power feed the opposite direction of what I've got. Now, wonder if anybody else has, come up with that, and maybe somebody has a solution other than just totally making your own power splitter or combiner. And with that, I'll wait to see other people's comments. So first, Charles, comment on right angle connectors. Have you seen the same thing?
Yeah, I can't say right off the top of my head which ones are best anymore, because even ones that look like what I thought were good in the past, I really have to check everything just to be sure. So yeah, now that people have nano VNAs and things like that, I'd really recommend just anything that you plan to use, check it, because everything is sort of oriented around the 2 gigahertz and down cheapy design market. And if it works there, then they'll ship anything. And so what used to work to 10 gigahertz, you can't any longer predict that it will. I would say it's actually better to go to a ham fest or a flea market and buy something as old as you can get it, because it's more likely to be a good 10 gigahertz. I mean, a good connector that's got better return loss. So yeah, mitered corners are what you're looking for. And anything that looks cheap, in other words, if it's not silver plated, chances are it's more cheaply made. So that's the only comment I could say. And on your powering the LNA type thing, you might look at some of the GPS antenna distribution dividers, because they'll pass power from one port sometimes up to the GPS antenna. And then, of course, coming back, the other 3 ports are blocked because they don't want all 3 or all 4 of the GPS receivers fighting for voltage control of who powers the preamp. So I've a couple of times actually taken regular passive power dividers and changed it so that only one port passes DC and the rest are DC blocked. That seems to be work the best way. Makes sense, Bruce?
Okay. Thanks, Bruce and Charles. Let's see. I think Jack Gansel, did I get you already?
Yeah, you sure did. I appreciate it.
Oh, okay. And John Roberts, I think, did I get you? I'm sorry, John Richards.
Yeah, you got me.
Okay. All right. I think, did I miss anybody?
I want to encourage folks to save their own copies of the chat. I think it comes out with the video as well, but you go to chat, and in the very top right, there are 3 little dots, and you can save chat. It shows up in your documents someplace.
And I will post the chat. I will edit it a little bit and make sure there's no personal information on it. I'll post it, and if you go to the YouTube video, it's under the More section, description section, along with a description. I actually use the AI generator on my software to generate a description in time, and then I put the chat underneath that. So a lot of good information under the description section under the YouTube video. All right, and we'll see the next event would be Drake Sands, Australia. Okay, thanks everybody.